Hello geometers, and welcome to the video lesson on basic geometry constructions. And this is really more about learning to use the tools that you have at your disposal than anything else here. So the first thing that I'm going to show you is how to work a compass and draw a circle. So to start out, a circle is a center point, and all points equidistant from the center. So in order to draw a circle, you need to know the center and you need to know the radius. Okay, so the actual distance, or that length, we call that the radius. Okay. So let's just practice a little bit. So if I needed to draw a circle using a compass, I put a dot on here. That'll be my center. And let's say I want the radius to be, 4 centimeters. So if you have one of the more old-fashioned compasses that has like a point on it, what I like to do is lay a ruler down and then put the pointy end at 0. And then just measure and stretch this compass so that it is about 4. And we try to be as precise in this as possible. So you see the pointy end here, and then you see the pencil end here at 4. So now then we can do this confidently. Just put the pointy end on the center. Whoops. And then it's actually easier to hold the compass in place and then just spin the sheet of paper that you have. Okay. And there you have it, just a basic construction of a circle. Now, next I'm going to show you some other concepts in building and constructing circles. Okay. So in this problem, we're asked to draw a circle through 3 given points. In this case, these 3 points. So, you gotta put the point here somewhere, and then draw a circle that passes perfectly through all 3 of these points. Okay? And you can see here, just by guessing and checking, it's going to be pretty difficult, and it's going to be pretty hard for us to do this well. Okay? So we have to use some of the geometric principles that we already know. So first thing we're going to do is make a triangle out of this. And then we know one very important fact is that the center of the circle must be equidistant from A, B, and C. Okay. And so this is assuming you completed some of the chapter 5 in geometry, but this idea then is to use the circumcenter. In other words, the intersection of the perpendicular bisectors of each sides. So I'm going to measure these sides, construct the perpendicular bisectors, and then where those 3 bisectors meet, that's going to be my center. Okay. So sort of fast forward a little bit, I measured out the length of AC, and then I figured out what the midpoint is that is, and I drew a 90-degree angle using this blue line here. Then I did the same thing with AB. This angle is 90 degrees. And then AC is it's very small, but it's right here. And where these three blue lines intersect, I have this point, which is called the circumcenter. Okay. Now, if I take my compass and use the circumcenter as my center, you can see that it's the distance from the circumcenter to C. Yeah, let me do this better. The distance to C is the same distance as it is to A. Okay, so the distance to C is the same as the distance to A, which is the same distance as it is to B. So if I do this and I just draw it accurately as I possibly can, we should end up with a nice circle that passes through all 3 points. I think I missed my measurements a little bit here with B, but otherwise I have a perfect little circle here. So this is, if you just kind of rewind the video, what we started out with was just 3 random points, and we were able to somehow build a circle that passes through all 3 of them. And the idea is that because the circumcenter is equidistant from A, B, and C. In other words, by constructing the circumcenter, we guarantee that the 3 red lines here, the 3 red lines are congruent. So let's call this Q. Remember that AQ, BQ, and CQ are all congruent to each other. Okay. Alright, so this is just some good practice using our measuring and constructing tools. And I'm going to go on to one more example where we create a circle that's a little bit more complicated. Okay, so here, our last problem, we're asked to draw the largest circle that we can possibly draw that fits inside of this triangle. Okay. And of course, we start out by guessing and checking, and maybe you adjust your compass, and you put some random center in here because this looks like there's a lot of space, and you turn. Okay, and there's a circle. That's a pretty good size circle, okay. But it has a little bit of a flaw, that we know that it's not the biggest circle because we could probably fill up some of this space some more, fill up some of this space, and definitely fill up some of this space. Okay, so at first, guessing and checking is not the way to go. What we should do in this case is to find the in-center. If you don't remember what this word means, you should look it up. Very briefly, it is the concurrency, or the concurrent point of the angle bisectors. Okay. In other words, what I'm going to do is cut all 3 of these angles in half, and then use the point where they meet as my way of constructing the largest possible circle. So I'm going to go and do that now. Okay. So first, I use my protractor to find the measure of angle A, and then found the angle that's in between that, and just constructed this angle. I'll show you how to do it with these other angles here. So let's go with angle B here. Okay, so I'm going to turn my paper. Hopefully you can still see. Put my protractor on this little dot. Make sure that this mark here at 0 is perfectly on top of the line. And if you look at the measures here, we're looking at the smaller numbers because this is an acute angle. You can't really see clearly on the video, but I can tell you that's 71, 2, 3. So half of 73 is about 36.5. So I'm going to count 35, 36.5. That's about this point right here. That means if I connect a line between B and this point, I should have my second angle bisector. So that means this angle here is congruent to its reflection. Okay. And then do the same thing with the last one. So just tilt my paper, lay my protractor down. This up here is about 35 degrees, so half of that is like 17.5 degrees. So 10, 15, 16, 17, so like right between 17 and 18. I think my measurements are slightly off, but because I know that all 3 lines, all 3 of these all 3 of these angle bisectors should match. So they should intersect at the same point, and basically these 2 angles are congruent, and this is the center of my circle, which is not bad, which is not that different from my my random guess and check here that I did at the start, but it's certainly a better solution. Okay. And then now we take our compass, put the sharp end here on our center, and we're going to stretch this end, the other end of the pencil end of the compass, to the side, and I just want to kind of test it and make sure that that's as far as it can go. I think it might be able to stretch just a little bit more. So from here, if we use our compass, turn it, now if this was drawn perfectly, then the circle itself should just barely graze this the three sides of the triangle. So the way we know that this is true is if we were to construct a 90-degree angle here. This blue line here, this is 90 degrees, this is 90 degrees, and then let's make one more right here, that's also 90 degrees. That the three blue lines should be congruent since they are all radii of the center of the circle. Okay, and we know that this works because the incenter here is guaranteed to give you these three blue perpendicular segments that are congruent, and we know it's the biggest circle because it has stretched and touched all three sides of the triangle. We can't possibly draw a bigger circle because that would be on the outside. So I hope you got a little bit of practice here. You had some fun playing around with your geometry tools. We have lots of computers that can do things perfectly, but there's a lot to be said about a person who can build, draw, and construct things on their own. Okay. And remember, how is it that we were able to do these, to do and create these circles and these shapes? It's using the geometric properties that we learned. Thank you for watching. Have a wonderful day.